Hello students, in today's lecture we'll see module number 5, numerical methods. So in this numerical method we'll discuss the many situations here. What is those situations and all we'll see in detail. We come across with situations having a data comprising a set of discrete value of the dependent variable corresponding to various of the independent variable. Means, for example, I can say that y is equal to f of x is a equation where x is independent and y is dependent there. So here in this module, numerical methods are discussed for the following situations: estimating to the desired degree of accuracy, the value of the dependent variable corresponds to a value of the independent variable. Also knowing the form of function satisfying all conditions on hand, refer to interpolation. So here I can say that so many situations are there where we cannot find the solution directly or in easy way. So in that sense, or in that situations, many dependent variable are going to be calculated using independent variable under this numerical methods. So here interpolations belongs to number of kind of situations of the numerical methods. So I can say that solution of polynomial and transcendental equations by locating an approximate real root or an interval containing a real root and subsequently improving the accuracy of the root. So here we are going to use important concepts. We call this interpolation. So I can see this interpolations, and we are going to find the real roots or approximate root. For example, I can say that you have seen your in the previous classes what is the how to find the roots of the given quadratic equation or cubic equation. Root means factors, making factors for the given equations and getting the values for x. So similarly, so sometimes we'll get a root, a real root, or sometimes we'll get what here approximate root. So usually approximate roots are going to be calculated by using the numerical methods. So those roots are not exact, so we can say that approximate roots, or I can say that we are going to improve their accuracy level to get what here, or to bring that result near to the exact roots. So let's see the detail. And evaluation of a definite integral without the actual integration of the function by using some discrete value of the function referred to as a numerical integration. So here in this module we are going to study one of the important concept, numerical integration. So how to use numerical for the integration, that concept we are going to learn here. So in general I can say that so we are going to use a numerical methods by using interpolation methods for the given equations. For I can say that transcendental equations and algebraic equations. We have two kinds of equations. We'll see that in detail, as well as we are going to evaluate a definite integral and using this numerical methods. For this we are going to refer what here some discrete value of the functions. So let's see what all those things in this module. Also, so here one of the important points are there. So numerical methods for transcendental equations and algebraic. Let's see what is that. Numerical solutions of polynomial and transcendental equations. So we'll see here. So numerical methods of finding approximate roots of the given equation is a repetitive type of process. So what do you mean by repetitive here? So to get a solution or to get a result accurately, we are repeating a procedure again and again to get what here? Result more accurate to the original result. So here numerical methods of finding approximate root of the given equation is a repetitive type of process known as iteration process. So already you have seen one of the concept, that is regular falsi in this matrices in your previous semesters, that is Rayleigh's power method. So in that Rayleigh's power method you have seen that, so you got first eigenvalue and first eigenvector, but we have repeated till we get a approximate eigenvalue and approximate eigenvector. So almost you have done 4 to 5 iterations. So that iteration process is nothing but a repetitive process to, and why we are applying that iteration methods or iteration process? To get a approximate result. Okay, in each step the result of the previous step is used and the process is carried out till we get the result to the desired accuracy. So this procedure already we have done, so same procedure will apply here again, but for a different way. Okay, now in this topic we shall discuss some numerical methods for the solution of algebraic and transcendental equations and simultaneous linear and nonlinear equations. So here two important points are there: algebraic and transcendental equations. Algebraic equations and we have two kinds of equations here: algebraic equations and transcendental equation. So what do you mean by algebraic equation and what do you mean by transcendental equation? We'll see here. So you can observe, so equations involving algebraic quantities like x, x square or x cube, so on, etc. are called as polynomial or algebraic equations. Okay, so for example I can take the equation as x square plus 2x plus 1, that is nothing but will come under algebraic equation. Let's see one example with for more clearance. So for example, so x cube minus 4x minus 9 equal to 0, one example. Or another example, I can say that x raised to 4 plus x cube equal to 80. So these all are whatever equations are there, it is, you can see that it is purely in the form of one variable and it is only a polynomial. So such kind of equations are going to called as algebraic equations. Let's see what is transcendental equation. Equation that involves non-algebraic equations. Non-algebraic equations means e raised to x, log x, sin x, tan x, etc. are called as transcendental equations. Means it mixture of what here, algebraic, sometimes algebraic term with this e raised to x, log x, sin x, tan x or any trigonometric functions are there. So for that involvement of those things are going to consider as a transcendental equation. So for example, I can take it as a example as x e raised to x minus 2 equal to 0. So this is one of the example I can say. And second example is if you want to take tan x minus 2x equal to 0, or one more example, I can say that log of 2x minus 1.3 equal to 0. So this you can see here. So x into e raised to x, so it includes what your term like e raised to x, log x, sin x, tan x, all three examples are there. So such kind of equations are going to consider for what here transcendental equations. So we have two kinds of equations. So equations of having purely a term like x square, x cube, so on will come under algebraic, and in equation including e raised to x, log x, sin x, tan x, and all for such kind of equations are going to consider for what here transcendental equations. Now we have very important concepts here, means for testing of this numerical solutions. So we have important property or important condition, I can say that. So for this I can say that very fundamental properties to get solutions here. So what is that? So we'll see, pay attention for this. If f of x is equal to 0 is a real valued continuous function of the real variable x, we have the following fundamental property. What is that fundamental property? So we'll see that if there exist two values a and b, small a and small b, means two values here. So for that we'll consider small a and small b, such that f of x has opposite signs. Means if I apply, for example, I have one equation. So one equation is what here, if I put for this, so f of x, if I replace x by what here a, I may get one answer which is less than 0. Less than 0 means negative. And if I put in place of x as b, so if I get positive, or the reverse may be possible here. If I put f of a is equal to what here, x is equal to a, I will get a positive value, and if I put f of b equal to is negative, so there is a two possibilities. Then there always exists at least one real root in the interval what value will choose, that is ab. So for that I will show an example here. See one example just for to show that condition. So I will take an example as, so x cube minus 4x minus 9 equal to 0. Fine. So this equation you consider it. So now for this I will consider f of x is equal to x cube minus 4x minus 9. So this is my equation now. So this equation we have to start putting the value from put x is equal to 0, what answer you will get. Put x is equal to 1, what answer you will get, check. 2 is check. 3, 4, 5, 6 means put x is equal to 1, 0, 1, 2, 3, 4, 5 all, if you go manually. Or if you want to use the calculator, I will show you here. So for example, if you put x is equal to 0, so I will make use of calculator. Go to mode option. So in the mode option, so you select option number 7, that is table. Press 7. So you will find f of x is equal to. So you can write this equation f of x is equal to by using alpha x cube, okay, shift cube, okay, then minus 4 into alpha x minus 9, we have minus 9, okay, then press equal to sign. So it will ask starting value, means what, from what value you want to start for x, it is asking. So I want to start with x is equal to 0, I will start, and end with how much here, x is equal to, I will put as end, means I want to check for x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, so on till 5. So I will put end with 5. And what is jump, means after 0, the distance between 0 and 1 is 1. 1 and 2 is 1. So step size is 1. So I will step, it is asking step. So press 1 equal to. So just you can see here, if x is equal to 0, the value is minus 9. When x is equal to 1, I will write it here. F of 0 answer we got minus 9. Then f of 1 answer is minus 12. F of 2 answer is minus 9. So you use center button to check the next value. F of 3 is plus 6. The next continue. F of 4 is 39. Then if you go one more, f of 5 is 96. Okay. Now, once you got this, you can see that. So we have negative, negative, negative value, positive, positive, positive value. So this is, I can say that less than 0, and these values are greater than 0. So I can say that. So these are the two nearest value. So f of 2 is negative and f of 3 is positive. So I will show that condition here once again. F of A is what here? Less than 0, that is negative. F of B is greater than 0. So two immediate values, or f of A is positive and f of B is negative. Alternate will be possible here. So then what we can say that, so the root is lying between A, B. So here A value is 2, B value is 3. So I can say that the root lies in 2 and 3. Means your answer for this given equation, answer will be in between 2 and 3. So that is the meaning here. So this is a general concept. So I want to show you how it works here. So we'll see again one more point here. Okay, so once again I will see if there exist two values A and B such that f of x has opposite signs. Say f of A less than 0, f of B greater than 0. Less than 0 means negative value, f of B greater than 0 means positive value, or f of A positive and f of B negative, then there always exists at least one real root in the interval AB. Fine. So this property is useful in locating an initial approximation for a real root of the given function f of x equal to 0. So this is very important. So we need to work out in that sense. Now we'll see one of the important note. Once we get a initial approximation, that is A and B value. So what happens? We'll see. If the value AB of x are nearer enough, then the numerical iterative method will be given the real root to the desired accuracy quickly. Okay. So that will get. So in some method, we have to locate. So in some methods, we have to locate an approximate root x is equal to x naught for starting the iterative process. Okay, so in which cases, if the magnitude says f of A is near to 0 compared to f of B, so we prefer to take x is equal to x naught as A value as the initial approximation. So just I will take back that problem once again to show this. So how to for whom we have to consider x naught, that is initial value in what here, f of A and f of B. Okay, so the answer of f of A or f of B who is near to 0, for that we have to consider for what here, x naught value, which is the initial approximation. Okay, let's see that example what we have solved. See here, we have taken these two values. Fine. So f of 2 equal to minus 9 and f of 3 equal to 6. So among these two, so you don't see the negative sign, just f of 2 is just value is 9 and 6. So 9 is near to 0 or 6 is near to 0 here if you consider the number line. Okay, 0, 1, 2, 3, so on. So here I can say that so on till up to 9 if you take. So here I can say that 6 is near to 0. So therefore if 6 is near to 0 means this 6 is near to 0. So for that I can say that our x0 value is 3, and 6 is because of what here? 3. If I put x is equal to 3, then only I am getting 6 here. So x0 value will be what here? 3, which is nothing but initial approximation. So these are the basic concepts for this numerical methods. So these are this is just a theoretical part, and we'll see in detail this numerical method for this transcendental equation and algebraic. So for this for our syllabus we have two cases, that is one method is regular-Falsy method and another one is what here? Newton-Raphson method. So both methods will see under this topic for numerical solution of transcendental and algebraic, or I can say that for algebraic one more name you can call as polynomial equations.